Extra example number 8. We're doing a confidence interval for the mean, for the population mean. And so if we do this completely in 4 steps, and only 2 of your homework problems tonight will be this state plan do conclude, then what we're trying to do is estimate, even though it kind of says that up here, we want to write it ourselves. Mu, and are we trying to find the mean number of toilet paper rolls? Yeah, the mean number of squares of TP. Okay, so that's what we're trying to do. We're trying to estimate that, and we only have the sample. So our plan is to construct a one sample. You'll see why it's important to know the names for these tests. It's a one sample T interval for mu if we have to meet the random, normal, independent. So random, the toilet paper rolls selected at random. To the independent condition is true because there are at least 180 rolls. So the 10% condition is met. And then now the tricky one, our sample size is it's not really small, but it's smallish. Small, n equals 18. So we have to check the shape of the data. And when you graph it, and on a test you would copy what you see on your calculator, but you graph it, there's going to be no outliers. And it'll be no outliers or strong skew. So we're okay.
There isn't.
There is?
No, there isn't.
Okay. Okay, so we're fine, and then now we're going to do, which is the easiest part, but let's write everything we know. So this is how I'd recommend it. When you did one of our stats, what'd you get for X bar? So you can make your calculator do the work, and you get 24.94. And then it'll say S sub X on your calculator, sample standard deviation is 2.86. And then the degrees of freedom that we're going to need is equal to n minus 1, which is 17. We're doing a 99% confidence interval. So that means we would do inverse T. The area is 0.5%, so 0.005. Be really careful on that. And degrees of freedom is 17. And that gives us T star equal to 2.898, almost 3 standard deviations. Above and below is what we're going to add to the middle of our interval. We're going to go 3 standard deviations above and below. And that makes sense. I mean, we want to be really confident, right? So you need a bigger net. So you're going to have more standard deviations above and below. So now we use our formula, X bar plus or minus T star, S sub X over root N. So 24.9 plus or minus 2.898 for T star times 2.86 over the square root of, be sure you use the sample size, not the degrees of freedom. And so you get 24.9 plus or minus 1.95, which gives us an interval between 22.99 and 26.89. So we have to write the conclusion properly for our 4-step. We conclude we are 99% confident. That we will use between about 23 and 27 squares of TP to absorb a quarter cup of water.